So this is the third problem on composite sections. A block shown in figure of weight 35 kilonewton is supported by three wires. The outer two wires are of steel and have an area of 100 mm square each, whereas the middle wire of aluminium and has an area of 200 mm square. If the elastic modulus of steel and aluminium are 200 GPa, 80 GPa respectively, then calculate the stresses in aluminium and steel wires. So this is the arrangement shown in figure. So the outer two wires are of steel. See here. So this outer wire and this one are made up of steel. So area of each will be 100 mm square. So 100 mm square. Whereas the middle wire is made up of aluminium and have an area of 200. And it is carrying this arrangement, it is carrying a load of 35 kilonewton. So P equals 35 kilonewton. So 35 into 10 raised to 3 Newton. So area of steel. See here. So there are two wires, each of area 100. So area of steel will be 200 mm square. So area of aluminium. So aluminium. So it is one wire having a area of 200 mm square. Clear? So this is area of steel AS and this is area of aluminium. So I will take it as AAL. Next, Young's modulus of steel. It is given that 200 GPa. So you will get 200 into 10 raised to 3 Newton per millimeter square. Next, Young's modulus of aluminium 80 GPa. So it will be 80 into 10 raised to 3 Newton per millimeter square. So here it is required to calculate the stress in the aluminium and steel wire. So that is sigma AL and sigma S. So sigma AL refers to stress in aluminium. So sigma S refers to stress in steel. So it is required to calculate stresses in the aluminium and steel wires. So we know the first assumption, strain in steel which is equal to strain in aluminium. Again, strain can be written as stress divided by Young's modulus. So here it is sigma S divided by ES equals sigma AL divided by EAL. So if you cross multiply, you will get sigma S into EAL equals ES into sigma AL. So here to evaluate sigma S, so it will be ES divided by EAL, which means Young's modulus of steel divided by Young's modulus of aluminium multiplied by sigma AL. Clear? So sigma S equals, So Young's modulus of steel 200 into 10 raised to 3 divided by Young's modulus of aluminium 80 into 10 raised to 3 multiplied by stress in aluminium. So sigma S equals, so here 10 raised to 3, 10 raised to 3, it will be cancelled. So 200 divided by 80. So it will be 2.5. So sigma S equals 2.5 into sigma AL. So this is your equation. So I will use the second assumption. Second assumption is P equals PS plus PAL. So total load equals load shared by steel plus load shared by aluminium. So we know that total load, that is 35 into 10 raised to 3 equals, so load can be written as stress into area, sigma S into AS plus sigma AL into AAL. So sigma S can be written as 2.5 into sigma AL multiplied by area of steel. Here it is 200 plus sigma AL. Again area of aluminium it is 200. So let me simplify this. So first 2.5 into 200. So it will be 500 into sigma AL. So 500 into sigma AL plus here sigma AL into 200. So here sigma AL is common, 500 plus 200. So you will get 700. So here it is 35 into 10 raised to 3. So now sigma AL can be calculated. So sigma AL equals 35 into 10 raised to 3 divided by 700. So sigma AL. So sigma AL comes out to be so 35 into 10 raised to 3 divided by 700. So you will get 50. So stress in aluminium. So it is 50 Newton per mm square. So this is your stress in aluminium. So now you can easily calculate the stress in steel because already you know the equation. So stress in steel sigma S equals 2.5 into sigma AL. So 2.5 into 50. So it is 125. So sigma S, it is 125 Newton per mm square. So this is stress in steel. Stress in steel. So this is your first answer. Stress in aluminium 50 Newton per mm square. So stress in steel 125 Newton per millimeter square.